All right, today we're looking at how to solve literal equations. So a literal equation is an equation where variables represent known values. Literal equations are used to give formulas like distance, speed, area, volume, force, time, temperature, etc. To solve literal equations, we isolate the variable and express it as a combination of the remaining variables. All right, so our instructions are to solve each literal equation for the indicated variable. We want to simplify any radicals. We want to rationalize any denominators. So the first one that we see, let me zoom in a little bit tighter. We're really given the formula where we're going to find Fahrenheit in terms of degrees Celsius. So what we're asked to do essentially is to rework this equation to solve for C instead. So I want to isolate the C right here. So first thing to do to get that piece right here, this term by itself, is to subtract away the 32. So we're going to subtract 32 from both sides. So now we have degrees Fahrenheit minus 32 equals 9 over 5 C, 9/5 of C. Now from here, right, I want to get the C all by itself. So to make that 9/5 go away, I can multiply each side by the reciprocal, 5/9. And what I do to one side, I'm going to do to both sides. So on the right-hand side, where I have 9/5 of C times 5/9, right, 9/5 times its reciprocal is really just 1. So I'm left with C all by itself. Right, I get that C is equal to 5/9 of F minus 32. Right, I could leave it like that, or I could distribute it. Right, if I distribute that 5/9 out, I can say that C, Celsius, is 5/9 of degrees Fahrenheit minus 5 times 32 is going to get me 160. And then it's like over 1 right here, right? 32 over 1. So 5 times 32 is that 160. 9 times 1 is just 9. So I say 160 divided by 9. Like I said, both of these are fine, right? I could leave it either way. And I've isolated C, degrees Celsius, in terms of Fahrenheit. Okay, the next one and 2 should be pretty familiar as well, right? We should recognize that that's just the equation for area of a trapezoid. But what's different is I want to get that base 2 all by itself. So I want to rework this area formula and solve for the base 2 instead. So here, first thing that I see is that I have a fraction. I have a 1/2 right here. So to clear that fraction, I can multiply both sides of my equation by 2. So now I have 2a equals 2 times 1/2, right? That just cleared away to just 1. So now I have base 1 plus base 2 times my height. Right, I'm trying to get that base 2 by itself. So next stage, I would divide out the h, divide out the height. Right, again, that cancels away 1 to 1. So now I have 2 times a, 2 times the area, divided by the height, equals base 1 plus base 2. Okay, and again, I want that base 2 by itself, so I'm going to subtract away the base 1 from each side, and I've done my job. Right, I've gotten my base 2 all by itself, so base 2 equals 2 times the area over the height, minus base 1 of a trapezoid. Okay, next up. Hopefully we recognize this one as our diagonal of a cube, right? We know that the diagonal of a right rectangular prism is the square root of length squared plus width squared plus height squared. And when all of those are the same, right, we can just call them all x. That just means it has to be a cube. So here I want to solve for x. I want to solve for the side length, right? So here I'm going to first just consolidate, right? The diagonal would equal big square root x squared plus x squared plus x squared. I really have 3x squared. Okay, I know that when I have a radical and I have a pair underneath, right, I can scoop up that pair and write one on the outside that represents the pair that's underneath. So my d diagonal equals x root 3. Okay, I'm trying to solve for x. So from here, I would divide each side by the square root of 3. Okay, root 3 over root 3 is just 1. So right now, I have x equals the diagonal over the square root of 3. But we know that we don't like having a root in the bottom, so we rationalize by multiplying by root 3 over root 3. Anything over itself is really just 1, so I'm still preserving the ratio. I'm writing it in an equivalent format, and I'm going to end up with x, right, the side of a cube, will equal the diagonal times the square root of 3 divided by 3. Okay, next problem. All right, problem 4. I can recognize this as the surface area formula for a cylinder. And here I'm asked to solve for pi. But what's interesting here is that I see pi in 2 places, here and here. Right? It's in 2 places, and both of those terms are on the right-hand side. So what I want to do is I want to treat pi as a common factor. It's not my greatest common factor, but it is a common factor. So I know that my surface area is equal to pi. I'm going to divide it out of both terms times 2RH, right? 2 times the radius times the height plus 2 times the radius squared. So I've divided pi out of both of those terms. And since I'm trying to get pi all by itself, now I can divide out from both sides that 2RH plus 2R squared. Okay, and when I'm dividing here something away from itself, that clears to just 1, and I have pi all by itself. Pi would be equal to the surface area of a cylinder divided by 2 times the radius times the height plus 2 times the radius squared. So here I'm really trying to give you formulas that you are familiar with, right, and how you're just isolating a different variable. Okay, these last 2 are just really pure algebra problems. So up here, slide that up. Here I have y equals x plus 2 over x minus 4, and I'm trying to solve this one for x. So here what's challenging is that I have a fraction on the right-hand side, and again I see x in 2 places. So what I want to do is I want to clear that fraction. So I could do 2 things. I can picture this as a proportion and picture that I'm really just cross-multiplying, right? I can do that. That's fine. Okay, or I can picture that I'm multiplying each side by my common denominator, my least common denominator, right? My least common denominator would just be x minus 4. So here I'm just going to write a little note, right? I could either cross multiply because it's a basic proportion, that's fine, or I could look at it as clearing my fraction. So multiply each side by that x minus 4. So if I visualize this just as a proportion and I cross multiply, so here I could say that y times x minus 4, right here I'm just multiplying on those diagonals. So y times x minus 4 will equal 1 times x plus 2. Okay, from here I'm going to distribute the y. So I have x times y minus 4y equals x plus 2. All right, keep in mind what I'm trying to solve for. I'm trying to solve for x. I have x here, I have an x here. So I want to keep those x's on the same side of my equation. So I'm going to subtract x from both sides. So now xy minus x minus 4y equals 2. Okay, then I want to move that 4y to the other side. I'm going to add it over. So add that 4y. So now I have xy minus x equals 4y plus 2. So I've reworked my equation to get every term with an x on one side. Everything else is now on the other side of my equation. So here I see that I have a term with an x here and here. So again, I'm going to treat it as a common factor. And in this case, it is my greatest common factor. So I divide out an x, leaving behind a y minus 1. Okay, on the other side, I still have 4y plus 2. Okay, last thing to do to get the x by itself is to divide both sides by y minus 1. Okay, and then here I get x equals 4y plus 2 all over y minus 1. Now that's as simplified as I'm going to get. All right, one more problem. All right, so here I have 1 over x equals 1 over y minus 1 over z. And here I want to solve for x. So now I see that I have 3 separate terms. They're all fractions, and I have variables in the bottom position. So if I want to clear my fraction, I want to look at my common denominator, my least common denominator. So if this one has an x, and this one has a y, and this one has a z, I'm looking at x times y times z. I'm going to cross that z so it doesn't look like a 2. So now if I want to get rid of my denominators, clear my fractions, I need to multiply each term by that LCD, the xyz. So here I'm going to multiply by xyz. Here I'm going to multiply by xyz. And here I'm going to multiply by xyz. Right? To keep my equation balanced, I have to multiply each term by the same thing. So over here, when I look at that 1 over x, right, times xyz, I see that the x's will cancel away 1 to 1. Second term right here, looking at xyz times 1 over y, those y's will cancel away. And then my last term here, where I have negative 1 over z times xyz, the z's will cancel away. Again, 1 to 1. So what I have left now is y times z is equal to x times z minus x times y. So here I'm trying to solve for x, and I want to look at where I have x in all of my terms, and I see that I have an x here and I have an x here. They're already organized the way that I want them to be. They're on the same side of the equation, so I don't have to reshuffle this time to get them on the same side of the equation. They already are. So now I treat x as my common factor. Again, it's a greatest common factor in this case. So yz equals x times z minus y. And again, to get x all by itself, now I can divide both sides by z minus y. And I'm at my conclusion, right? I've done my job. I've gotten x all by itself. So x equals yz over z minus y. And that's my final answer. So again, for literal equations, all we're doing is we are isolating a different variable. We're solving an equation for a different variable. All right, that's all I have for today. Have a good day.